Welcome to day 2 of our 15-day beginner data science sprint. Yesterday we understood what data science really is. We learned that a data science project starts with a question, not with an algorithm. Today we will learn the Python needed to begin analyzing data. We are not going to learn every feature of Python. That would take a long time and most of those features are not required when you are just getting started with data science. Instead, we will learn Python through one practical question. Can a few lines of Python turn a list of marks into a useful student report? Suppose we have the marks of a student in 5 subjects. Looking at these values, we may want to answer questions such as what is the student's average mark? What is the highest mark? What is the lowest mark? How many marks are at least 75? Should we describe the overall performance as strong or needing improvement? By the end of this lesson, we will write a Python program that answers all these questions. Before writing any code, notice the workflow. We have an input, the marks. We perform some operations, calculate, compare, and count. Finally, we produce an output, a small student performance report. This is already a simplified version of the data science workflow. Now let's work in this notebook. The name is day underscore 02 underscore Python underscore essentials underscore for underscore data underscore work. Add a text. We will add a text cell with the heading day 2 Python essentials for data science or data work. Now create the first code cell. So code cell 1, I am writing student name equals Arav and print student name. Let me write in the same code cell. Before running this cell, pause and predict the output. What do you expect Python to display? Now run the cell. The output is Arav. A variable gives a name to a value. Here the value is Arav and we have given it the name student name. Variables help us refer to information without repeatedly writing the original value. For example, we can also store a number. Passing mark equal to 40 and print passing mark. The variable passing mark now refers to the number 40. The equals sign in Python does not mean that the two sides are mathematically equal. It means store the value on the right inside the name on the left. Before running the cell, tell me what do the square brackets represent. So let's run the cell and we see the output. These square brackets represent that the values form a list. A list stores an ordered collection of values. Instead of creating 5 separate variables, we can keep all 5 marks together in one list. The order is preserved. We can access individual values using their position. So print marks 0 and print marks 1. This will give me 72 and 81 as the output. Python begins counting positions from 0. Therefore, marks 0 is the first value. Marks 1 is the second value. Marks 2 is the third value. This zero-based counting may initially feel unusual, but it becomes natural with practice. Now let us calculate the total and average marks. Before we run the cell, tell me what will sum marks return? What will len marks return? What Will the average be above or below 75? Now let's run the cell. So the output is total 385, number of subjects is 5, and average equals 77.0. The sum function adds the values in the list. The len function tells us how many values the list contains. We calculate the average using average equal total by number of subjects. Python gives us 77.0. The point 0 tells us that Python is representing the answer as a decimal number. However, this average alone does not prove that the student performed well in every subject. A student could have a high average and still have a very low mark in one subject. This distinction is important in data science. An output gives us information, but it may not tell us the complete story. Before we run this cell, predict the answers by looking at the list. This is the list that we are using. So let us now run the cell. The output is highest mark is 90 and lowest mark 65. The max function finds the largest value. The min function finds the smallest value. At this point, our code can already summarize the marks using three useful values: average, highest mark, and lowest mark. A program becomes more useful when it can make decisions. We want to assign a performance level based on the average. Our rule will be if the average is at least 75, label it strong performance. Otherwise, label it needs improvement. Before we run the code, tell me that what status should the program assign. We know the average is 77. The output is status strong performance. The if statement checks a condition. Here the condition is average greater than equal to 75. The greater than equal to symbol means this symbol means greater than or equal to. Because the average is 77, the condition is true. Python therefore runs status equals strong performance. If the condition were false, Python would run the code inside the else section. Notice the spaces before the statements under if and else. These spaces are called indentation. Python uses indentation to understand which statements belong to a condition. Incorrect indentation is one of the most common beginner mistakes. Now change the marks temporarily. Recalculate the average and run the condition again. The program is now assigning needs improvement. The code has not changed, but the output has changed because the input data changed. A list is useful when we have an ordered collection of similar values. But what if we want to store different kinds of information about a student? For example, name, marks, class, attendance. For this, we can use a dictionary. A dictionary connects keys to values. In this dictionary, name is connected to Arab, class is connected to class 10, marks is connected to the list of marks. We can access individual values using their keys. So print student name, print student class, print student marks. The output will be Arab class 10 72 81 65 90 77 list. Lists are usually accessed using positions. Dictionaries are accessed using meaningful keys. This makes dictionary useful for representing structured records. A real dataset may contain thousands of records with fields such as name, age, city, marks, or purchase amount. Now we want to count how many marks are at least 75. We could inspect every number manually, but the approach would not work well if we had hundreds or thousands of marks. Instead, we can use a loop. Before we run the cell, tell me how many lines of output do you expect? The output is 72, 81, 65, 90, 77. The loop takes one value from the list at a time. During each repetition, the current value is stored in the variable mark. Now we can combine a loop with a condition. Before we run the cell, tell me the count the qualifying marks manually. The values that qualify are 81, 90, and 77. So the count is 3. The output is marks at least 75 is 3. We begin with a count at least 75 equal to 0. Every time Python finds a mark of at least 75, it adds 1 to the count. This pattern is commonly used in data work. First, start with a count of 0, examine each value, then check whether it satisfies the condition, then finally increase the count when the condition is true. The code tells us that 3 marks are at least 75. However, it does not tell us why the remaining 2 marks are lower. We would need more information before drawing conclusions about the student. Our analysis currently works for one list of marks. Suppose we want to analyze another student. We should not copy and paste all the code every time. Instead, we can package the logic inside a function. This cell defines the function, but it does not run the analysis yet. To run it, we must call the function. A function packages repeatable logic. The word def tells Python that we are defining a function. The function is called analyze marks. The value inside the parenthesis is the input to the function. Here, the input is a list called marks. Now we can analyze another list without rewriting the logic. The same function will produce a different report because it receives different input data. This idea is extremely important in data science. We often write reusable functions for cleaning values, calculating statistics, transforming columns, evaluating predictions, creating reports. Now, without using technical jargon, explain the most important output from our program in one sentence. A suitable answer could be the student scored an average of 77 with the highest mark of 90, so the report describes the overall performance as strong. The goal is not simply to repeat the numbers. The learner should explain what the numbers mean. Communicating an interpretation is part of data science. Now it is time for the learner challenge. Modify the analyze marks function so that it also calculates the lowest mark, counts how many marks are at least 75, displays both results. Do not show the complete solution immediately. Start with the first useful step, lowest equal min of marks. So you must not jump to the solution immediately. You should start with the first useful step, that is lowest equal min of marks. Then you can do the operation and get the expected output. Take this as the input and this is the expected output. So try for a few minutes and then I give you the complete solution. This is the complete function. Now let us call the function and we get the expected output. Let us trace the program from top to bottom. First, the function receives a list of marks. It calculates the average, highest mark and lowest mark. It then creates a count starting from 0. The loop examines each mark. When a mark is at least 75, the count increases. Finally, the condition assigns a performance status based on the average. The function displays the complete report. This is a small program, but it combines the essential Python tools we need for beginning data work. Printing the output is useful for learning, but a data science program often needs to reuse the results later. So instead of only printing the values, we can return them as a dictionary. Call the function. We can now access individual results by writing their keys. Returning a dictionary makes the output easier to reuse in another calculation, table, chart, or application. Our function assumes that the marks list contains at least one valid number. This input would cause a problem. Analyze marks with an empty list. The program cannot calculate an average from an empty list. It also assumes that every value is a valid number. This input would also cause a problem. Real world data often contain missing, incorrect, or inconsistent values. Handling those problems is part of data cleaning, which we will study later in the series. For now, our program works with a small, clean list of numerical marks. Today we learned only the Python needed to begin analyzing data. We used variables to give names to values, lists to store ordered collections, dictionaries to connect meaningful keys with values, conditions to make decisions, loops to process multiple values, functions to package reusable logic. Most importantly, we used these tools for a clear purpose. We converted a list of marks into a simple student performance report. The new capability we gained on day 2 is we can now use Python to process a collection of values and produce a meaningful summary. But we must also remember the limitation. The report summarizes the marks, but it does not explain why the student received those marks or whether the data is complete or accurate. Data analysis provides evidence. Interpretation requires context. Before ending the lesson, we have two tasks for you to complete. First task is use this input, generate the complete report, and you should get these expected values. Then second task is write a one sentence interpretation. A suitable interpretation is the student performed strongly overall with an average of 80.8, although one subject had a mark below 70. You do not need to master the entire Python language before working with data. You need to understand a small set of tools and know when to use them. Today we used Python to analyze one list. In the next lesson, we will begin working with NumPy, which helps us perform numerical operations more efficiently on larger collections of data. Complete the learner challenge and write your one sentence interpretation before moving to day 3.